Hello, everyone. This is a technical walkthrough, another one for the upcoming, or actually live Ethereum Attackathon. By the time this is going to be live, we're already going to have bug reports incoming. We are today joined by Xiaowei. She's from Consensus Layer, and this is, I guess, one of the most important technical walkthroughs out of them all. Xiaowei will present the, how you whiteheads can interact with this layer, how, I hope this explanations will help you, of course, with bug hunting. So without further ado, Xiaowei, please feel free to introduce yourself, share the screen, and go with the explanations.
Thank you, team. So hello, my name is Xiaowei. I am part of this, the maintainer of this consensus layer specifications. So maybe we can start with the code base. So let me share my screen to you.
Let me know if you are able to do that. If you have the permissions.
Oh, and we'll just run. Yeah, I think that's the wrong tab, but we can start from there. Okay. Could you see my screen?
I see GitHub at the moment. Yep.
Right. Okay. So this is the project itself. It's the consensus layer specification. So the target for this bounty, this hackathon, is the markdown file, the spec. So Ethereum, in Beacon chain, we have many hard forks, and they are named by phase zero. From phase zero start is at the start point of the beacon chain, and then alter the Bellatrix and blah 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 till the DNAP, and the next hard fork would be Electra. So these are the in production specifications that all the consensus layer code devs, the CO clients, they using this spec to as the reference to implement their softwares. So our team, we maintain these specifications with researchers and code devs together. So this is the source document for everyone to discuss that, okay, what features will be included in the next hard fork, and then we implement the spec together here. So I think this, let me show you what the contents look like. So when we start from phase zero, the beacon chain phase zero, you can see there are many markdown files. The most important document is the beacon chain. So this is a markdown file with Python code, and we define this types, constants, and then in the following we describe how you enter this the transition functions. So this is likely the how one the pre-state, the pre-beacon state, and that will we can apply the block onto it, and then the result will be the post state after state transition. So this, you can see, this is the entry functions in the, and that will invoke other helpers to process the state transition. So yeah, this is the file of PySpec would look like. Just markdown file, and with human readable language in comments there. You can see, yeah, sometimes we have some comment to introduce what this types is for and what this helper is for. Yeah. So if you have the knowledge with beacon chain, then you can somehow understand like how it is used. And then we also have other files for different areas. So think the most critical bugs will be in the beacon chain. So if there's any consensus failure here, it's likely the client has also implement the same code there. So that's why the stakes is important to the mainnet products as well. So for the stake, I think if you found a bug that post the consensus failure across the different clients, and you can also, when you are finding bugs of other CL clients, you can also look into the spec to see, okay, how they should have implement the CL logic like this. And the other scope, we also have like fork choice. The Ethereum fork choice is the Casper. The Casper is a G. So this is, we define what the validator should do when they receive a block. And in here, they will like add this block onto the local database and apply date transition here. So like the markdown files are relative. They might invoke outputs cross files. And then there's also like what happened when the client received attestation. Okay. So in the fork choice test, the fork choice test case combination, it will be probably more complicated than beacon chain. So I think it's also important to see if you found the fork choice bugs, because that's probably the thing that we were more difficult to cover all the edge cases. So you can also look into it. And then what else? Okay, so the researchers write this document, but how we taste it, that's also important. So for since phase 0, we this is my old implementation from this year March, so it's a bit outdated but still valid. So in this GitHub file, you can find the specification, the markdown files that are just pure functions. But then you can also find we try to build the markdown files into Python, into the pure Python software. And this is the elf in the setup.py that do this dirty work behind underneath. So all this markdown file will be combined together through this spec builder helper to transfer the markdown files into the .py files. And so the phase 0 specs will be transferred to phase 0 beacon chain spec. And then the altair will, it's the next half fork will include the previous helpers and the additional helpers of altair all together, then combine into the altair beacon chain stakes. Yeah, that's how we do the visioning in the space. So the build file will look like. So how to share my screen of VS Code here. 1 second. Yeah, because there's no built version on PySpec GitHub. It also you need to build the PySpec, the built executable spec locally. So
is there a guide on how to do that?
Yes. Here in the taste folder, there's some document in the structure of how can you build the PySpec and how to run the PyTaste to verify the code. So things like that. But let me see. One second. Oh, like this is. Okay. This is how this built Python file look like. Each limit. It's actually for the Capella, for example, just for example, it's like a 4,000 lines code in total, with some extra helpers that are not included in the scope of hackathon. So you can see the build file will be just pure Python. Like this, and then just go through a bit. Okay. So I think the way you can try to find the bugs is like you can actually run the test and then maybe write some new test and try to tackle it and found if there are something that was not covered and should be found. So I think that's the way we usually found bugs. I mean, from the maintenance point of view. Yeah. And also know that this is also how the PySpec has 3 responsibilities. One is it provides the specs, the Python specs for people, for readers to read. So we wanted to the Markdown files to be very readable for not just for devs, but also like people who are interested in Ethereum. So this is the .NET version. So like first I show you like how phase 0 we will introduce all because that was the initial fork, so it has to implement all the helpers from beginning. But now we are at the .NET stage. So in the .NET fork, it's like we are adding some new code onto the old code base. So we only have to add the new helpers that we want to use, or like we can override the old helpers. For example, you can see some like modified file. For example, this one is a modified process attestation. So this function was implemented from phase 0, but we changed something inside here, and we will have some commands to tell you like, okay, this line was changed and due to which EIP. So we can also use this info to find like, okay, this EIP, what's the contents and what if this modification is correct according to the EIP content. So like this is the resource you can cross reference. Yeah. What else? From here. Yeah, so you can see the lines of DNF is much shorter than phase 0. Just like this. And about the scope, quick reminder is that so like the P2P helpers are not they are in the Attackathon scope, but the code we don't have much code to describe how the P2P network should be working on. But for example, these are just English spec. We don't have we didn't make it executable. So therefore we didn't paste it with code. So I think this part is also, you can think about if there's any maybe DAS attack could happen in Ethereum mainnet, and then see if the client implemented it correctly accordingly, because we also don't have test vectors for client teams to use. And they also have this validator guide. This is recommend behavior for the honest validators to perform their validators. So I mean, the CEO class implement this logic. However, if you break this logic, if you break some behavior that we recommend, it won't be like consensus failure on mainnet, but still somewhat we recommend you to do to like at the time that you should attest, then you should broadcast your attestation. So things like that. So you can also use this to reference for the reference. However, this validator guide is not in the scope of this Attackathon. What else? Right. So we also have this. Like for example, this is the cryptography library specification. This is for the KZG polynomial commitment. So if you are interested in the applied cryptography and audit, then you can also look into it. Also, we do have tests for all these functions.
And it's going to be in scope for the Attackathon, right? The cryptography part.
They are, yes.
Mm-hmm.
Mm-hmm. Yeah, I think like almost all stakes are in the scope, but just the validator guide is not. And I can also show you how the tests look like. So we use this PySpec to it also serves as a test generator for clients to use the test vectors. So here I have some generators for each different topics. We have different test formats for them. For example, the sanity tests are the most simple ones. Like we have the block test. So it's like you have the pre-state, and then the post-state, and the blocks that you could apply to the pre-state, and then the result would be this post-state. And the generated test vectors will be in another folder here. Sorry, another repository. So for example, this DNAP, sanity, say blocks test. I can see how these are the tests we already have. And then they show you example of the test. Zero. Yeah. Okay. So this is what the test look like. Oh, all right. Reminder that the tests are not in the part of the attackathon. We wrote so many tests, but these are not in the scope. So you can see how we yield the pre-state. So here we would export the serialized state, beacon state file, and then we would create some test scenario here, and then here we would apply the block into the pre-state. And then, oh, sorry, this is not the case. In this case, it's invalid. So there's no post state. So if there's any error or like exceptions happen in the state transition, it will say, okay, there's no post state, and that implied this is an invalid case. And for the valid case, then it will yield the post state. So all the CL clients can use these test vectors to verify their code base to ensure that the logic is the same as the state defined. I think that's like like the scope and
Wonderful.
how
Yeah,
the beginner can see use it.
wonderful. I'd say, yeah, I think this was a very good overview of the scope. Xiaowei, my question will be, so you covered a few known issues. I saw that, so a few bugs that you already encountered. Any similar findings, or are there any findings that were discovered during audits, if any? So were there any previous audits and were there any discoveries there that you may flag? If they're public, of course. I think that's a good addition here. Yeah.
Right. So I'm not sure if we have done any like audit work after phase 0, but we have many, bugs had been not many, not many, but some bugs had been found by community, by devs previously. I think one interesting case, let me look into the bug. Yeah, it was me. Oh, I mean, I think most most cases were fixed before they are amended. So it's like a maintenance bug. But also like there's one or two cases are we had to fix this quietly was for the fork choice. Because the fork choice is failure is it it's sometimes the attack the issue it causes is it won't be consensus failure. It could be sub fork like or like the bugs that makes validator easier to miss one slot, miss the slot they should propose. So we did have the case. Like give me some time to find it. This one. Yeah. So I think in this one. Yeah. So there was some more complicated attack model that for example, like you can withhold if you it can, as an attacker, you can I mean, for us, we can assume like, okay, if someone that has like over 2/3 of validators of all the mainnet, what would they do to attack the chain? Also, that's the very least possible cases, but for assuming attack model, we can make assumptions on it. And then also like, what if the attacker has like 33% staking, and how can they attack? So this attack threshold matters when we make assumptions. So that also will reflect to how servant it for the attacker zone. Like if this attack could be initiated with only 1% of the staking, then that would be serious. And if this attack can only be initiated with like 2/3 of the total stake, then it's like, yeah, we know 2/3 of stake can likely rewrite the history, but at what cost? Because it would definitely get the stash, get stash, or like we have social recovery to, social layer fix to change the finality after the attack happened. So, or like how the attack will attack Ethereum itself largely. So I think based on just different assumptions, you can get different results. So I think that's also what the hackers to think about how to attack this can keep it in mind.
Yeah, I think this is wonderful. Anything else? Anything else we can cover? Anything else we can flag as similar issues, or anything else of interest for security researchers?
I think generally, I wonder if you can find interesting things in the P2P protocol. I think that's the area for the spec itself, hard to, we seldom to tackle with. But client thinks they might have other protections. So, it's like so client doesn't have to implement the, assess the specs. They might have some optimization skills. So, I think the important thing is like you can, no matter if you are auditing these specs, you can learn how to read it to help you audit other softwares easily. And like we do have some randomness tests in the specs, but I think if you can tackle some parameters that we didn't randomize, then that will be helpful as well. And yeah, also there, there might be bug for PySpec only, not the client things. Or then the reason might be like the language of Python itself and how we use them. So that's less critical to Ethereum mainnet. But yeah, I think it would be very helpful if you found it. What else?
I think if you know, if nothing comes up to your mind anymore, I think that's that's totally fine. I'd say we're in a pretty good spot here. Covered the code base itself. You pointed out the in-scope assets, and then we went through the previous known issues and the bugs. Honestly, I think this will be more than enough for security. So just go on, please.
Sorry. One more thing. I'll just give you more external reference to understand it. So, actually, the initial PySpec is written by Vitalik, and then he also write this annotated spec to explain more about PySpecs. So for example, this is the base 0 version. So he added more explainers to the logic. Because for seeing this is the diagram. So because for the spec, we wanted it to be readable, but in the meanwhile, it's for engineer to tackle. So we try to make it more clear, more clean. The least version of Vitalik's documents are some more for beginners to understand them. And also, Ben Edgerton has another annotated speculation files. I think, he might change he changed the URL. So if you found the content is like hard to understand, you can come here to understand what's the background knowledge and to found external resource for that. Yep, I think that's it.
Wonderful. I'm quite sure that most of our whiteheads already know Vitalik's documents by heart, so they they all know how like Ethereum works. So they're more interested in the small details that you uncovered today. So I think that's perfect. The documentation is, of course, I think it's attached to the main page, so they'll know where to look at, where to read. That being said, Xiaowei, thank you for your time. I think we can end the recording here. Final disclaimer. Yeah, guys, everyone who watched till this moment, till the end, that's for security researchers. The Attackathon probably has already started, and it's going to be live till January 20th, 2025. So it lasts for 8 weeks, and it offers rewards of up to $1.5 million. Huge reward pool. So go grab those bugs, and hopefully this recording was helpful for you. So thank you very much.
Thank you.